So we're graphing a squared equation. This is basically telling me that because I have that power of 2 in there, that this is a quadratic equation. Remember, that means that it's going to be based off of the graph of y equals x squared. And it's going to be the same graph. It's just plain old y equals x squared. What is the shape of y equals x squared? Well, we call it a parabola. What's that shape look like? Kind of that U-shaped graph. That's a graph shape that we're going to be seeing here. What we need to know, though, is still where does it start from? And that is actually answered by the numbers that are added or subtracted in the original equation. So the x minus 1 tells me that I'm shifting 1 in the x direction. Minus goes to the right. The minus 4, it's hanging on the end. So that tells me that it's going to be going up and down. Minus on the end goes down. So I'm going to be putting my first point right 1 and down 4. Once you have that point plotted, now it truly is just making the same graph that we would for x squared, just starting here at that point instead of starting at the origin. And so to make that graph, we go over 1 and up 1. Then we go over 2 and up 4. Because remember, 1 squared is 1. 2 squared is 4. Just like 3 squared would give us 9. Whatever number I'm squaring is my x. And whatever I get out of it, that's my y. So in other words, I square whatever I go over, and I go up that amount. And so I would go over 3 and up 9. If I went over 4, how far up would I need to go? Well, what's 4 squared? 16, yeah. Does that fit on my graphing grid? No. Doesn't quite fit. So those are all the points I can plot on the right side. I then head over to the left-hand side. And so over there, if you don't remember the pattern, you could always still do it the same way. What's negative 1 squared? Positive 1. So you can see it's actually going to be the same thing as what we just did on the right side. So over 2 up 4, over 3 up 9. And then we've got all of our points plotted. We're now ready to draw the curve in. Question though, when we draw the curve, should I be drawing the curve as a solid curve or a dashed curve? Notice that sign there after the y. That is a less than. Not or equal to. Since it is not equal to, that tells me that it is going to be a dashed line. And so you can go ahead and just draw that in dashed, or you'd be welcome to actually draw it in solid with your pencil and then just erase the dash marks into it. Either way you do it though, extend it out to the edge of the graphing grid, and you got your parabola. Now that we have our parabola, we do have to do the one last step, which is our shading. Since that is a less than symbol, does that tell me to shade above it or below it? Below, exactly right. And so I'm going to be shading everything below my parabola on this one. Now this example is unlike anything we did yesterday, at least directly. Yesterday we did some graphing inequalities, but we only did lines and absolute values. But notice we were able to extend that same knowledge to a quadratic because we know how to graph the quadratic. Or at least, hopefully we do. And we're going to keep practicing along the same kind of line. So I got one more graph for us to practice based off of yesterday's work. So please now graph the square root inequality. Now, if you're having a little bit of trouble remembering how to approach this, start by thinking about what's the general shape you'd expect. Well, if I'm going to be graphing square root, I'm going to be ending up with this shape of graph. You know, if you squint really hard, maybe they kind of look alike, the square root symbol in the graph. So that's a kind of a way that you can remember which one goes with the square root here. But that's what we're going to be doing. We're going to be making that shape of graph. It's just a matter of where it starts from. The plus 6, it's in with the x, right? so it's going to move it in the x direction, plus, it's going to move it to the left. The plus 2, it's hanging on the end, so that's got to be my up and down. In this case, plus 2 is going to be moving it up 2. So you're going to put your first point, left 6, and up 2. And then be making your square root graph from there. Again, if you don't remember what square root graph looks like, though, you can be looking back at our notes from last week when we actually put in there what the parent function, just y equals the square root of x, looked like. Because it's going to be the same graph from that point. All right, so when I then go and start plotting the points, I'm going to be going over 1, up 1 from that first point. And then I'm going to be going over 4 and up 2. Because remember, whatever number I'm going over, that's the number I'm taking the square root of. So I'm taking the square root of x to get my y value. And so it tells me to go over 4, for instance, and up 2. Just like I then would go over 9 and up 3. And then what's the next number that I can take the square root of? 16. What's the square root of 16? 4. Does that fit on this graphing grid? Well, remember our first point over here was at negative 6. From negative 6 up to a positive 10, that is 16. So yes, it does fit, but only barely. So we can go ahead and plot that point there. Will this graph be solid or dashed? I look up here to know. Because I see that it's less than or equal to, the equal to part of that little line underneath it, tells me that yes, it will be solid. So go ahead and draw the solid curve that goes through those points. So basically it was just the exact same thing as when it's equal to, except we just have one more step here. And that's to go ahead and shade it. Now for this particular case, since it's less than or equal to, will we shade above it or below it? Below it, absolutely. And so if I start shading it below here, I'm just going to work in from the right side. You notice most of the way it's very straightforward, right? But then I hit this point. Well, if I'm going to be shading below the graph, how do I shade to the left of that first point? Because there's no graph there for us to shade underneath, right? Well, since there is no graph there for us to shade under, there is no shading underneath that point. So this shading that you see here underneath the graph, and only directly underneath the graph, is the only shading you need. This is our complete graph right here. Now as you take a look at solving this equation, I know some of you are looking at it and basically saying, where'd the numbers go? Well, this is an example of what we call a literal equation. A literal equation is one that's just got a bunch of letters in it that we're going to have to move around instead of it just being numbers. Well, when solving a literal equation like this, though, you solve it the same way you would as if there are numbers in there. So I'm looking at the equation up here, and I see that I'm trying to solve it for y. Well, what's in the way of the y being by itself? We got the 2 and the r there. Well, the 2 is being multiplied by y. The r is being added. Which one do I get rid of first, the multiplication or the addition? We get rid of the addition, yeah. It's like the order of operations, the old PEMDAS, except we're going backwards through it because we're undoing this thing. So I need to get rid of the addition subtraction first. The opposite of adding r then is subtracting r. So we're going to go ahead and subtract r from both sides of this thing. So then on the left side, I'm left with just 2y. On the right side, if I do BC minus R, what does that equal? Well, just BC minus R. That is what it equals. There's no way that we can simplify it past that because the variables are different in both of those terms. So there's no way to combine them through subtraction. All right, so that means this line is good. We got one line left, and that's to get the y by itself still, so I got the 2 in there. What am I going to do to both sides to get rid of the 2? Yep, we're going to divide. And so, divide by 2 there, and divide by 2 there. Now be careful how you write your answer at this point. So we got y equals, you got a couple formats you could use for writing this. My preferred format personally is the fraction style of division. BC minus R all over 2. This would be correct. But it's not the only way you could have done it. You could also write it as BC minus R with a division symbol in the 2. It's just that if you're going to do that, you need parentheses around the BC minus R. Kind of why I like the fraction way of doing it more. You don't have to remember the parentheses. Because this right now says that the whole BC minus R is being divided by 2. This says that only the R is being divided by 2. And of course it's the whole side that's being divided by 2, so we would have to have the parentheses if you do it that way. So now going on to solving another one. But this literal equation is actually a lot like another equation that you've already solved a few times in here. You've already solved proportions in here, just with numbers in there. But your process is the same. The technique is the same. And I'm guessing for most of you, that means that you're cross multiplying, which is good. That is right. But I have a question for you. Do you know why cross multiplying works? So let's take a look at why this does work. I can show you here. It might make it a little bit easier. Let's say I want to get this z out of this side of the equation. Well, right now it's over z, meaning dividing by z, right? Well, the opposite of dividing by z is multiplying by z. If I do that, that'll cancel this z out. And when I multiply z into the left side, that means that I'll have zm in the numerator. But then I'd have zm over h. I'd want to be rid of the h too, right? Well, if I wanted to get rid of this divide by h, what would I do? We'd multiply, right? I'd have to multiply both sides by h. And multiplying that h would cancel that h out. And then I'd multiply h over here, which means that I'd end up with d times h. If we just cross multiply, what do we end up with? The same thing. So why does cross multiplication work? Because basically what we're really doing in order to solve this is we are multiplying both sides by both denominators. It's just that when we do so, it ends up being this nice pretty little thing where we draw the circle, and we say that mz equals dh. That's why that's working. That's what you're doing in the background, is you're actually multiplying both sides by h and both sides by z. All right, a little side note here before we proceed with this. The biggest mistake I see when people cross multiply is I'll see them give an answer that looks like this. Oops, I got to get the right order here. So I'll see them write down mz over dh. But this is not right. Can you tell me why that's not right? What's kind of an indicator that you could look for that would tell you that doesn't quite work? Yeah, notice the original had an equal sign in it, and this doesn't. Well, if in the original we're trying to figure out what h equals, how would this help us figure out what h equals? There's no equal sign, right? There is nothing you can actually do mathematically that makes an equal sign disappear. If there's an equal sign in the original, there would have to be an equal sign in the result. Hence, can't work. But we see the fraction at the start, and we kind of really want to keep the fraction there, but the other way that you can remember is that the purpose of cross multiplying like that is actually to get rid of the fractions. So if you do that right, there should be no more fractions left behind. All right, so now let's go ahead and finish this thing out. I have mz equals dh. I still want to get the h by itself, so I'm going to divide both sides by d, divide by d, divide by d, and we end up with the final answer of mz over d equals h. Actually, I want to line that up. There we go. So mz over d equals h. Now I know for some of you, you don't like it being the equals h on the right-hand side. Yes, you can rewrite it as h equals mz over d, but if you're going to do so, do it as a separate step like that. Do not jump straight from here to here. Because if you do, you just did two steps at once. You divided by d and then switched the sides. And if you start doing two algebraic steps at once, bad things tend to happen. And so stick with just doing one thing at a time. Technically speaking, though, it doesn't actually matter which side the h is on, as long as it's just an h on that side. And so we've seen a couple literal equations, but today's not just about equations. We're also going to continue the theme of inequalities. So we're going to be solving also some inequalities today along the way and mixing them up together. Now, as we look at it, what's different about this from some other stuff that we solved is that this one's an inequality instead of an equation. Well, let's take a moment here. If this was an equation, so if that was an equal sign instead of an inequality, what would you do first? We would actually have to move that 9 over, and we'd do that by subtracting, and I'll point out why it's got to be subtraction here in a moment. But because this is an inequality, that doesn't change that. We are still going to start by subtracting 9 from both sides. Now, I need to take in a little aside here because I do see a lot of people who will say, well, don't I move the 9 over by adding it? Because right now I see subtraction, and the opposite of subtraction is addition. Well, yes and no. If I were trying to move the 5, that's being subtracted. The 5x is being subtracted, so that would get added. But right now this 9, notice the 9 is positive. And since this 9 is positive, I want to be able to do something that makes this add to 0. And so that's why I subtract, because 9 minus 9 will make it into a 0 and make it go away. All right. So if I do that work, I now have 15 greater than or equal to negative 5x. Now again, pay attention to the operations. Notice this minus right here, this negative, that is a negative, not a subtraction symbol. And so this is really negative 5 times x. So if I want to get that out of there, I'm going to have to now divide both sides by negative 5. And when we divide both sides by negative 5, I get a negative 3, and I get an x, and I'm guessing this is the answer you have on your paper, but it's not right. Why? All right, so that should be a negative 3 then, right? Okay, so is that all? Well, actually not. There is something else. Yeah, it's actually the inequality symbol is off here at the moment, because we just divided here by a negative number. Anytime you multiply or divide both sides by a negative, it flips our inequality symbol. And so it's actually going to be negative 3 is less than or equal to x. It's got to flip it. Now notice, this is the number that determines if it flips it. I don't care if this is positive or negative up here. All I care about is what I'm dividing by. If that number is negative that I'm dividing by, then I have to remember to flip the inequality symbol around. And that's the only time we have to remember to flip that, is if we multiply or divide both sides by a negative. On to the next problem. Write it down and solve it out, or at least take it as far as you can here. If you're feeling it all stuck, I would suggest that you start by getting rid of the parentheses. Because most of the time, once you get rid of the parentheses, you'll know what to do from there. So I got rid of my parentheses. Having done that, I now am just trying to figure out how do I get the n by itself. Well, you notice the things that are in the way of that are the 10t and the 6. The 6 is being multiplied. So I'm actually going to save that, and I got to get rid of the 10t. Well, if I'm going to be getting rid of 10t from this side, what operation am I going to do with the 10t? We're going to subtract it. Because the 10t itself, that's positive. And so if I want to get rid of it, I have to subtract it. And when I do that subtraction on the left-hand side, I got 15AW minus 10t. Notice here that those are not like terms. This first one is an AW term. The second one is a t term. So I cannot combine them by subtraction. So I got to leave it like that for the moment. On the right side, notice I got rid of the 10t, but notice what's left behind then. The whole negative 6. n is still there. So make sure you remember that negative in front of the 6n. It'll be easy to forget if we aren't careful here. All right, so then last step. In order to get the n by itself, I got to get rid of that negative 6. So I'm going to divide both sides by negative 6. And again, I'm dividing something bigger by that, so I tend to prefer more that fraction notation for doing division. So I'm going to write it as 15AW minus 10T all over negative 6. And that equals n. You could have actually done this problem, by the way, in a different way. If you were working through it, if you came up with 10t minus 15aw over a positive 6, that's equivalent. That still equals the same thing. You'll notice that it's basically just multiplying top and bottom both by negative 1. And so if you came up with that as your answer, that's totally fine. One other thing I do want to point out here, just because you're going to be doing some work like this on your own here soon, you're going to be doing some algebra on your homework for tonight, you'll notice that I at least try to line up my equal signs vertically. Try to line them up above each other as I go. That's a great way to keep your work organized, and I definitely would suggest you try to keep your equal signs lined up as much as you possibly can. That, and of course, show every step. You got to show all the steps of the math as you go through this. All right, here we're faced with something we haven't had to solve before, certainly not today. This is what we call a compound inequality. Because they basically are saying that we took two inequalities and we put them into one together. Really, this one inequality statement that you see up here, it actually represents two separate ones that have just been squished together. It represents negative 7 is less than 1 minus 2x, and it represents the 1 minus 2x is less than 1. It's two separate statements that have just been written all as one. But knowing that will also help you know what to do and how to solve it. Because let's say I'm just looking at this first one here. If I wanted to get x by itself, what would I do first? Yeah, we'd subtract 1 there. Well, what about on this one over here? What would I do first if I want to get x by itself? We'd subtract 1. And so notice that what we'd end up doing is we'd be subtracting 1 from the negative 7, we'd be subtracting the 1 from the 1 minus 2x, and we'd be subtracting the 1 from the 1. We don't have to turn it into two separate ones in order to do that. We can actually just say, well, since I have to subtract 1 from here, rather than saying what I do to one side I have to do to the other side, I can say what I do to one side I have to do to all of the sides. And we can actually work with all three pieces at the same time. And so if I subtract the 1, that gives me a negative 8 is less than negative 2x, and that is less than 0. Before I put it up here, take a moment. Go ahead and take that last step on your own. And I want you doing it on your own first because I'm dividing here by a negative. And really, I just wanted to see, did you remember our one specific rule? Because notice, I'm divided by a negative. Anytime we divide by a negative, I flip those inequality symbols to go the other direction. And yes, that goes for both of them. So that's your final answer.